Okay, so the next thing I want to do is I actually want to start building out this project. So let's go ahead and let's keep this. We're going to delete some of this code. Let's keep this structure for now. And I'm very particular about C library includes. These are standard. These are user library includes, and then these are my user defined functions. So what we're going to do now is make a configuration file that kind of sets up some of the data structures we're going to be using. So if you remember the structure from last time when we used the I actually don't know where I just saved that. Hold on, let me figure out what I just did. So let's go to the Linux files on my machine, my C project, source. Oh, good, it's in the right place. So it needs to be our code needs to be in the same place. So we're going to say if not defined, just the same structure as this. If this has not been defined, we're going to define it. And this is a little bit tricky, but what happens here is every time you include this header file, right, helper functions in main, you can only define things one time, which is a compiler thing. But essentially, I showed that earlier, right, when we defined x twice, you can't do that. So what this does is says, all right, here's the include, then the compiler will set up all this stuff, and if the compiler sees this has been defined already, it doesn't define it. You just kind of follow the structure and everything falls into place. And don't think too much, just follow this syntax and you'll be fine. Somebody way smarter than me wrote the thing. So that's what I say. So this is what we're going to do. Now the first thing we're going to do here is I'm going to include config.h. Okay. I have some code that I've already worked through, and then I'm going to make, and then let's run it and see what we can do. Great. So what we're going to do is we're going to copy and paste these, and we're going to put them into our configuration file. So what we're going to do in C, there are no classes, just type defs. So this is actually the predecessor to a class in C++. A class is a user-defined data type, really a data structure. Because that's all you're doing is behind the scenes you're just structuring something in memory. So the syntax for this is type def struct structure, and then you have like int x, int y, int z, and we're going to call this our configuration parameters. Okay, let's go ahead and do a quick build on this and see if we've done everything correctly. So what we can do now is we can actually say in main I can go like this. Let me go ahead and delete this code now because I don't think we need it. Configuration params. Then I can say params. Now I can also declare a pointer like this. These are both valid. And the difference between them is that this is an object, right? It's an actual object. But this is a pointer to an object, to a configuration params object, meaning this object. So what we have to do is this. Because it's a pointer, we actually have to allocate the memory for it. And this is really goofy, but it's just syntax you kind of get used to with time. Size of config params. So, shit. What do you need to make? So there you go. This is kind of the general setup. And what this does is it allocates the memory for this object, right? Yay! And then, if you remember our kind of idea with an array, you can assign to it. So I can say like params.x equals 5. And then I can also say with my params pointer x equals 25. And these are both valid statements, and I'll go ahead and print them. Print this all off. So this is kind of the idea. Great. And we'll see in a second kind of what's important with pointers. So I'm going to go ahead and delete all this, and I'm going to open some of the code I've been working on, because I'm just going to copy and paste a lot of it in here. So I was working here, I think, here. Let me open these two files. Yeah, so this is where it starts to get kind of fun. So what we're going to do is make an audio session. And the audio session has 3 variables inside. It requires a PortAudio stream. I didn't know this. I just looked it up online with ChatGPT and the internet. You don't have to do it this way, but I did it this way, so this is how I'm going to show, so we can get a good example of a good project that's pretty difficult. A data way to index and save data, and then 3 optional. Optional configuration parameters. And this will be more obvious why I did a couple iterations of this, but it'll be more obvious why I'm doing this when we get to the making the Python module part of this, and then importing this module into Python. So we're going to do another typedef struct. Typedef struct. We're going to call this recorded data, and we're going to have don't have to have a pointer to the samples, so this is going to be a float pointer to samples, and then an int for the index, and we'll see what that's useful for in a second. Next, we're going to make a variable or a structure that can hold an audio session. So essentially, if we had multiple audio devices, I could set variables and start running multiple streams of data, but we'll go through one step at a time. So what we're going to have inside here is a configuration params pointer to config params, and we're going to have a recorded data object called data. And then I don't remember if I need anything else. So this is samples, configuration parameters. Let me open the config file for that and see what we did. We also need a PA stream, and that's important too. So this is a PortAudio stream, and we need the stream pointer because that's what it requires. I just ChatGPT'd what these functions require, and it told me. Sometimes you shouldn't think too hard. Oh, I didn't spell that right. There we go. Great. So, much in the same way that we just did the example with our small struct, you can see how this structure is defined, this structure is defined, and then I can create instances or objects of these structures. I prefer that to be that way, and this to be this way too, inside of this audio session. So just for now, be comfortable with the syntax. This object comes from the PortAudio, the PortAudio library. Okay, so now let's go to main, and we're going to make an audio session pointer called session, for lack of a better term. what we're going to do first is we're going to make the audio session. So I'm going to copy this function into our header file, and then I'm going to copy the actual code. No, I'm not. I'm going to do this live so we can understand what's going on. Okay. So what this will do is it'll set up the audio session. Great. Let me do a quick compile and make sure I didn't make any spelling errors. Unknown type. Okay. So this tells me that I need to do this and take it here. I also need to put it inside here. Audio session. You know what I'm also missing? Let's use our brains. Where is audio session defined? In our configuration file. But do you see the configuration file? Here or here? No. So this error came from, where did this error come from? This came from our header file, helperfunctions.h. So what I need to do is I need to take this and I need to include my configuration file here and here. So this is how my program knows that these other files exist, or other functions and structures and data structures exist. Okay, so the first thing we need to do is take this, and we're going to take it and put it inside this function. And then we're just going to return session. And why am I doing that? Because what this will do is it'll create an audio session. It'll populate all of our variables for us. Now, what do we need to do? Okay, the first thing we need to do is say equals audio session memory allocation size of audio session. Now this is where C is kind of fun and also a little bit scary. I need to include this because this is part of this function. The standard library is what supports memory allocation. We did that earlier in a different video. We need to allocate the memory for all of these variables. So data is a recorded data malloc size of recorded data. Great. Now we can leave this alone for now. Let me make sure I'm doing this correctly. Yep. Okay, cool. So we're good so far. So we have to allocate memory for all of our index equals 0. Initialize the audio session. Let me comment this out. Initialize the audio session data structure in memory. The key is that this is the allocation of memory for the audio session data structure, which is just 3 pointers. So this doesn't allocate all of your data or all of the memory you need. It just allocates the 3 pointers here. Great. This doesn't allocate this is just the pointer to the samples and the index. So we still haven't allocated memory yet for the samples themselves. We'll do that in a second. The next thing I want to do is I want to set the session arrow, because this is a pointer arrow. What was the last thing we had? Stream, that's right, equal to null. We'll set this equal to a null pointer for now, so that we have have initialized all of our variables after this. So next we need to do this. Samples equals malloc equals, this is a float pointer with memory allocation size of the number num samples. Size of float times num samples. And we haven't created this yet, but what we're doing here is we're allocating memory for an array of size 32 bits times number of samples. And then I can do this. So that it's clearer. Okay, so the next thing I want to do is, oh, I forgot about our configuration params. Session dash config params arrow. What did we even set? What do we need to set? So this is what we need. I'll talk through this in a second. This is just what the program requires. It took me a while to figure this out. You need a sample rate, how fast you're sampling the audio buffer. You need frames per buffer, which is, but we'll get to that as the program grows. A number of channels we're going to use, the duration, and then the number of samples. So let's go ahead and in here, let's assign, let me put these out like this so I remember how to spell them. We assign the sample rate to the input sample rate, and then, oops, this will give me an error. We're going to assign the frames per buffer to the frames per buffer. Then we're going to assign the number of channels to the number of channels we input. And we're going to assign the duration to the duration. Oh, and this is capital D, so they don't get named the same. I think you can name these the same things. That just makes me nervous. Okay, the last thing we need to initialize is session config params num samples. I think that's what it's called. Let me check out num samples. Now this actually is some math. So what we're going to do is say, what is the math behind this? So num samples is the sample rate times the duration. So you have a cycles hertz, which is number of cycles per second, times seconds, which dimensionally gives you one dimensional analysis says this is 1 over seconds times seconds, which equals unitless. And what it returns is the number of times you sample times the duration. Sorry, the number of times you sample per second times the number of seconds you sample for. That gives you the total number of samples. So what we're going to do is take our duration and multiply it by our sample rate. Okay, so a lot of math. I'm hoping that it's all good. So let's go ahead and do this. And no index. What did I call it? Session. Oh, it's dash. Let's work through these errors together then. Index. So index is part of record. So it should be. Index is part of recorded data, so it should be dash data dash index or arrow index. Num samples undeclared. It is undeclared. What I actually want is this. This variable is not anywhere on here. This is what I want. Yay! Okay. So we have successfully set up our audio session, and then there are some things that you can do that are fancy and say like, oh, if this is null, this session was not successfully, blah, 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 blah. So, great. Let's go ahead and call this from main. So let's take this, copy, paste, and then let's make our audio session like this, session equals, and then let's make our pointer variable, because this returns a pointer. Make audio session returns a session, a pointer of type audio session. Okay, so that's what this assignment is good for. The next thing we need to do is actually define these, and they have to be defined in a specific way. Not really specific, but there are some standards. So int sample rate is 4410. This is standard for audio sampling. If you do like music stuff, this is 256. This is what ChatGPT told me the frames per buffer is on this. And then int num channels equals 1. This is 1 for mono, and then 2 for stereo sampling. And then the duration is just the sampling you want to do in seconds. Duration equals, let's do 3. You can sample up to 5 here before this times out. Okay, let's go ahead and compile this. And then let's do a quick run. Segmentation fault, core dumped. That's not good. I wonder if I need to... Oh, I wonder if that's what it is. Dash config params equals config params alloc. I need to allocate memory for... So I allocated the memory for my audio session. I allocated the memory for my recorded data variable. I set this equal to 0 because it's just an integer, so there's no... So after this step, this is allocated memory for a float pointer. And remember, the float pointer stores the memory address of the actual, the memory address of the array, not the array itself. So, and the int. So that's what you've allocated space for. You didn't allocate space yet for this. So I think that's what my problem is right now. All right, beautiful. Okay, so let's go through this. Now, this is somewhat confusing, so let's go through this kind of slowly. This audio session, right? This makes sense because a lot of people, like, you're familiar with programming. This is a pointer to the variable called samples. What's weird is that you can allocate the memory custom. That's why it's dynamic. Pointers are dynamic memory. This could be one memory address for a single float variable, or this could be 25 array elements. But all you're storing here is the pointer to that. What this line here does is it allocates the memory for the actual variable samples, right? So if you remember, like, if I do this, this is kind of the equivalent of saying my pointer dereference, or go, or assign a value to the memory address stored by the pointer. Okay, that's what this is. Wow, I spelled that wrong. Memory. That's what this is doing. So now I've allocated space for. This is convention, right? This is a floating point variable, or a pointer to a float variable type, which is confusing, but when you start using it, you just kind of get what's going on. Okay, so you're allocating space for the size of a float, which is 32 bits, times the number of samples, which is 4410 times, I don't know, 3? Yeah, 3. So you allocate space for that array. The next thing we want to do, I'm going to go ahead and copy this function, because I don't remember what I was even doing actually. Now this is interesting, and this is what we did before. So you can see how I'm going to modify session is through accessing the values stored by the pointer. So this takes input memory address of the audio session object. And that's how we're going to modify this, because you can see this function has void return type, meaning it doesn't return anything. So we're going to modify the session now through this function. Yay! Alright, so let's scroll down, wrong file, to here, and then this is required to set up the stream. So I'm just going to copy and paste this in there. This initializes the stream. This is a weird, actually, C is weird because this initialize actually sets up your hardware. So this makes hardware changes. There's no variable stored. This is just an integer it returns, either 1 success or 0 failure, or 0 success, 1 failure or something. I don't remember, but that's all. This actually makes hardware changes. That's what PortAudio does. So that's kind of cool, kind of crazy actually. So let me just straight up copy and paste setup stream, because this is something I just ChatGPT'd. Because I did not. One thing you start to learn is like there are things you should spend time on, and then there's this kind of shit where I could read someone's online nonsense, or I could just figure out how to do this. So again, we don't need to pass this PortAudio error variable because this is a hardware choice, right? This is actually interfacing with the hardware. So this is let's set this up so we can call this and make sure we don't have any errors, and then I will talk through what's going on here. Set up the stream with our audio session. Okay, so what we're going to do now is, if we recall the header file, this takes a pointer to an audio session data structure. So it's looking for the memory address of this structure. So if you remember, this returned the pointer pointer of type audio session. We can assign that here because this variable is a pointer of type audio session. Great. So now we can pass this into our audio stream or setup stream function, which is defined here. And then we can go in here and let's go through what this does. So of course we have our sprints that tell us where we are in the program. That's great. I like doing that. So what this looks for the first, I don't remember what these inputs were, and it doesn't really matter. So this is a floating point variable, which is why we defined our samples that we'll eventually use as float, because you can do, I think you can do short, which are 16-bit decimal signed numbers, blah, blah, blah. So this is bizarre because it's weirdly notated, but this here returns to you the remember, this session is a pointer, and this is accessing the value stored in the memory of stream, but we don't want that. We want the memory address of this stream. Sorry, this returns what's stored here, which is a stream. Right, this variable is of type PA stream, port audio stream pointer. This is goofy. It took me forever to figure this out, but this actually doesn't want the pointer to the audio stream. It wants the pointer to the pointer for the audio stream. So pointer to the pointer for the audio stream. That's weird. It's super goofy. But what it's doing is it's modifying the pointer itself. So what does that mean? It's behind the scenes. It lets you do stream modifications and stuff that is going on in the PortAudio open default stream. Great. So I'm gonna change this to null, and I'm gonna change this to null for now, and we'll see what we're kind of doing there in a second. So the next thing we need is a sample rate, which we can access using our pointer notation to go and grab the value stored here, and the value stored here. Much in the same way we grab this. This is a stream pointer. These are integers, right? This is a stream pointer, so by doing this full statement, we take the memory address of a stream pointer, which is super goofy, but what can you do? It's all in a day's work for those who code in C, which will be you pretty soon. Let me make a print statement here, and then say finish down here. So now we're really gonna see if we have done well in making this work. All right, so let's do a CMake. Let's do a make. Nice. What does that say? Stream successfully opened. All this output is from this initialize, so I don't have any control over that. There's ways to get around it, blah, 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 blah. This is actually the thing at the airport I thought wasn't working, but it turns out that it actually did finish so like, yay. So there we go. Stream successfully opened because we didn't return an error code or whatnot. All right, great. So the next thing we need is to stream. So I'm going to copy this definition, and you can see again, we are taking an input that is the memory address of the memory address of an audio session object, or a pointer to an audio session. And then we define this in code as stream samples. Okay, so now this is where it gets really fun. This is where we actually start to stream our audio. Now these are commands that I looked up from ChatGPT. So this takes a stream pointer, as input. This sleep takes the time in milliseconds as input, and then this takes a PA stream as input. And you'll notice that, a stream pointer as input. You'll notice that this is how we're able to keep modifying our data structure, is that we have this session variable that's a pointer. So we're passing around memory addresses, and that's how we're able to access, that's how PortAudio is able to access and modify our stream based on the configuration parameters we give it. Additionally, it's how we're able to set up our stream and then take data out of it. So that's pretty cool. One thing I noticed is that I did not define milliseconds, so I'm going to go to the configuration file and define that as milliseconds as 1000. So I think you have to put them in parentheses, and there's no semicolon. So let's build this to make sure I'm not like just totally tripping balls. Okay, now let's go to the let's copy this over to our main, and let's comment this, stream the samples, and then we'll pass it our session pointer. So again, this this is a pointer, just has a memory address stored as a value, and then here we create a session pointer variable and we assign it to our copy in main. And now this is a memory address that we're passing. So every time we do this, we're passing memory addresses for these functions to alter. Okay, now let's run this and see how we do. 1, 2, 3, yay! Now let's run it with 5 and see if we can go count to 5. 1, 2, 3, 4, 5. You see the green thing open? That's perfect. And now we're streaming some audio, baby. So the next thing we need is called a callback function. And what does that do? So let's look at it. So I had to modify this a little bit from our good friend ChatGPT, but because I didn't know what the hell this took, so I don't even care. I just want the project to work so I can learn how to do the next part, which is to wrap a Python module. So this audio callback is interesting, and I'm going to comment out a lot of it. So let's do this. Let's comment this out. Yep, perfect. So what this function does is, as you sample, right, as the buffer gets full, it'll look for a function and it'll execute that function. So what you do is you put this name here. So every time the buffer gets full, it's going to go to this function, this audio callback function, defined like this, and it will act on whatever code is in here. So what I'm going to do first is I'm going to put it like this. So there's a couple of guards you have to put in here. I'm just going to do this. I think this won't cause any problems. So actually, let's get rid of that for a second too. Okay, so all we're going to do is print the first 10 samples from our audio buffer. So what we're getting inside of this is an input buffer, and this is a little bit interesting because we're taking this input buffer and like, let me actually look up what this does. I don't know. I forgot what that line did actually. But nevertheless, I can find out. Let me turn on my internet. Let me go ahead and connect to my internet here. Okay. Typecasting and pointer assignment. All right, so that's not super useful. Oh, I see. So this is an array. They're passing in an array. You kind of have to read the documentation to know that, which I didn't do. So what they're doing is, one of the things that you do in C is you don't always pass a type. And what that lets you do is, essentially it says like, the type of the function is void. Right? So const, let me say const. Const means you have read-only access. So what C is saying is this. So the type of the function is a void pointer. So you know it's an array because the documentation said it's an array. That I didn't read the documentation. Great. So what C says here is, hey, the user is pretty smart and knows what variable type they want to store the data as. So my function doesn't care, i.e., as long as it's some kind of pointer or some kind of memory address that they pass to me, I won't cause an error. I don't care, as my function in C doesn't care. So the user has to change the function type. Now, we put in a 32-bit floating point number. Now, that's why here we cast to constant means you have read-only access. I could remove this const if I wanted to, but I don't, because you don't want to mess with whatever is tied. This variable could be tied to something very important inside of your stream, so you don't want to mess with things sometimes. So what this is doing is assigning this this pointer input buffer into a local variable here. Great. And then if you remember here, this is shorthand for this is pointer notation, right, from our arrays earlier. It's going to the index 0 of the array and grabbing the value, index I equals 1 and grabbing the value. So let's go ahead and run this, and let's see if we did okay. Audio callback is undeclared. Did I include it here? What is going on? I did include it there. Did I save this? Static and audio callback. Let me just return PA continue. Did I spell that wrong? Audio callback. Did I mess up a spelling? PA continue undeclared. That's super weird. What's going on? Let me look in this file. That's really bizarre. It should have access to this, right? Yeah, it should. Yeah, because I include... Oh my goodness. You know what I'm missing? Include helper functions.h. Oh my god. Oh, I need to recompile this. Maybe it's not uppercase p, maybe it's lowercase. It is in fact. Okay, so this function is written by PortAudio, and it's looking for either a continue or complete. I just looked that up in ChatGPT. I don't know what that means. All right, let's do this. Yay, so now we've got sample output data. That's great. So let's go ahead and let that run. So the next thing we want to do is we want to be able to grab this data. And the way we do that is like this. This is really cool. So here, we're going to pass our session. That's cool. We're actually passing the pointer to our session variable. So we've gone through, we've initialized, we've created a session in here and assigned it to our copy in main. And now we're passing this memory address into our setup stream and now our stream samples. And along the way, it's getting modified into whatever we need, however we need to modify it. So I've kind of shown the solution already, but this is pretty important. What we're gonna do here is this. Let me get that out of the way. Let's do this first, actually. I don't want to do that. So I'm going to remove their loop, And if the buffer, this is a safeguard, so we don't start grabbing memory that doesn't exist. If the buffer didn't get assigned to anything, we're just going to return at this point. Now, what we're going to do is for j equals 0, we assign j up here. I just followed the notation ChatGPT used. I could say int as well down here. While j is less than the frames per buffer. Well, I didn't spell that right. Oops. That's the variable here, what the number of frames are. I don't even know what a frame is. I think a frame is the number of data points in the audio buffer. So I think it captures 256 at a time, 256 at a time. J++. Okay, so what we're going to do is we're going to take our session data index, and we're going to say equals session data index plus 1. So anytime we have a sample here, right? Anytime we get a full buffer to read, we're going to increment our samples. So what I'm going to do is print out the index right now. And then let's do this and let's run. Woo! Yay! Done. Now in main, I'm going to go back here and actually do something pretty cool. Let me print out printf session index data index equals. Let me do an integer printout and then a new line, and then we'll close this, and then we'll do session dot arrow data arrow index, and then we'll say final session. Now let's run this and see what happens. Woo! Nice. So now you see how, since we're passing memory around, all these functions are able to modify the memory, and at the end, we actually have data in here inside of our session, our audio session object, and that's pretty cool. But we don't have data yet. We now need to do this. So inside of this, what we're going to do is say session data at samples. What did I say down here? Samples at samples data index equals in at j. So we're now taking the input array pointer, and we're indexing over it, and we're assigning that value to our samples array at index, whatever the current index is. And I just realized I didn't spell that right. And then we're going to increment by 1. So we're assigning samples at index equal to whatever this is. Great. And then we increment index by 1. Wow, I didn't spell that right. Great. Let's do this. Woo! Perfect. So now, if I actually go back here, I can show that I have int x equals 0, while x is less than session, the session data index x++. What we're going to do is print out session data samples at this, and then like that. So we want X here in the first part, and then we want session data samples at X. So now let's do this. What did I just botch? What did I do wrong? 44. Ah, I didn't close that. All right, so now we're inside our callback function, and now we're in main, and that's pretty cool. But you can see we didn't assign anything. Oh no, what's going on there? That's super weird. What? That's really odd. Let me work through this. No, that's all right. That's weird. That's super bizarre. I wonder what's going on there. Oh, damn, I'm so dumb. These are floats, not ints. C strikes again. Oh, that's a F, not an I. It's a float, not an integer, so it truncated to 0. Oh, I'm so dumb. Yay. Perfect. All right. I think this is actually a pretty good place to stop because this video will get super long, but you can see kind of the structure of what happened. And yeah, it's pretty cool. This is our project so far. We're sampling the audio, and we're able to pull it off of the audio object in this on this computer.